Καλησπέρα, θα τελειώσουμε το σύστημα ψύξης ενός πλοίου ουσιαστικά με το τελευταίο κομμάτι που αφορά τη συντήρηση των συστημάτων που αποτελούν το δίκτυο του ψύξης ενός πλοίου. Είπαμε πάλι, θα είναι στα αγγλικά.
After completing this chapter, the learner will know the maintenance requirements of a diesel engine cooling system, know the reasons for using chemical treatment in a diesel engine cooling system, know the basic principles of how chemical treatment protects the system. When a diesel engine cooling system is operated with good quality water, which is correctly treated, then maintenance is minimal, and the system should give long-term operation with few problems. Lack of or inadequate treatment will lead to scale deposits and corrosion of the system components, which may result in failure or overheating. The only general maintenance required is to keep the coolant levels topped up and to maintain the correct concentration of treatment in the system. Care must be taken when draining the system containing treatment chemicals, as they may pose a pollution risk. Disposal should be in accordance with the material safety data sheet and any MARPOL requirements.
Εδώ, όπως καταλαβαίνουμε, είναι πάρα πολύ σχετικά για την ασφάλεια που καθορίζει η MARPOL. Η MARPOL είναι κάτω από τον άιμο, καθορίζει τις προδιαγραφές για την ρύπανση του περιβάλλοντος, αλλά και κυρίως και για την ασφάλεια των ναυτικών. Πάντα πιστεύω και νομίζω ότι όλοι το καταλαβαίνουμε ότι η ασφάλεια των ανθρώπων μας είναι το α και το ω, γιατί το θέμα είναι να μπορέσουμε να κάνουμε τη δουλειά μας, γιατί και το βαπόρι δεν είναι και εύκολο να έχουμε άμα γίνει ένα ατύχημα, καταλαβαίνετε τις δυσκολίες, και δεύτερον και να γυρίσει ο ναυτικός υγιής στην οικογένειά του.
The system components, such as the pumps and heat exchangers, will require periodic maintenance to ensure satisfactory performance. Circulating pump impellers and sealing rings, often referred to as wear rings, shaft bearings and shaft seals, will need to be replaced periodically in accordance with manufacturer's instructions. It may also be necessary to clear debris from impellers occasionally. Heat exchangers may need to be manually or chemically cleaned periodically, with seals and anodes being replaced as required. System valves will also require periodic overhaul, including reconditioning of seat faces and repacking of glands.
Νομίζω ότι είναι αυτονόητο ότι πρέπει να γίνεται επιθεώρηση του συστήματος, ειδικά από τις αλαμάστρες και όλα αυτά τα οποία μπορούν να κάνουν οι σωλήνες μας, και κυρίως ουσιαστικά το νερό, παρόλο που είναι απεσταγμένο, άμα θερμαθεί, δημιουργεί κάποιες ιδιότητες οι οποίες είναι διαφορετικές, γι' αυτό βάζουμε και τα ανάλογα χημικά, βέβαια με τις προδιαγραφές που δίνει ο κατασκευαστής και με την ανάλογη προσοχή βέβαια.
The quality of the fresh water used for the first charge and topping up is critical for good performance of the system. Normally, the water will be produced on board in the fresh water generator and should be good quality. There should therefore be very low levels of dissolved solids in the water, so scale formation should not be a problem. The water will still require treatment to bring the alkalinity to a suitable level to prevent corrosion in the system. This will be achieved by the correct concentration of a suitable water treatment. It should be noted that any of the treatments which are normally soluble in the water will actually cause the total dissolved solids content of the water to increase. Excess concentrations will therefore lead to possible deposits on the heat transfer surfaces, which can cause overheating due to the insulating effect.
Εδώ η ποιότητα του νερού, νομίζω ότι το καταλάβαμε αυτά που έλεγε, ότι αφορά βέβαια το νερό το οποίο χρησιμοποιούμε, το αλάτι είναι πάρα πολύ διαφορετικό, αλλά και το απεσταγμένο νερό, το οποίο το παράγουμε από τη βαπορέτα. Αυτό είναι το σύστημα της βαπορέτας, το οποίο η βαπορέτα είναι ένα μηχάνημα, το οποίο κάνει δύο δουλειές. Η μία δουλειά είναι να παίρνει τη θάλασσα και να την εξατμίζει με τη βοήθεια της θερμότητας. Συνήθως στα πλοία μας αυτό γίνεται είτε με τη βοήθεια του ατμού ή με τη βοήθεια του νερού της ψύξης, της κύριας μηχανής ή των ηλεκτρομηχανών, αλλά και της κύριας μηχανής, κυρίως της κύριας μηχανής, Βέβαια, επειδή το νερό της κύριας μηχανής βγαίνει γύρω στους 70-75 βαθμούς και το νερό σε μία ατμόσφαιρα βράζει στους 100, πρέπει να κάνουμε κενό όσο χρειάζεται για να μπορεί να βράζει στους 70-75 βαθμούς και αυτό το κάνει με το τσιφάρι. Το δεύτερο κομμάτι λοιπόν του νερού αυτού είναι εφόσον το αλάτι είναι βαρύτητα μένει κάτω και από πάνω το νερό το οποίο είναι σε ατμό, με την μορφή ατμού, όταν συμπυκνωθεί γίνεται απεσταγμένο νερό. Και βέβαια αυτό γίνεται και ένας έλεγχος πρωτού πάει στο δοχείο μας που έχουν τα πεσταγμένα. Υπάρχει ένας ελεγκτής ο οποίος ελέγχει το ποσοστό του αλατιού, συνήθως 15 ppm, 15 ποσοστά στο εκατομμύριο, ώστε να μην υπάρξει δυνατότητα και η σιγουριά να μην υπάρξει αλάτι να διαρρεύσει στα άλλα συστήματα, τα οποία και ειδικά στη μηχανή, με ό,τι προβλήματα μπορεί να δημιουργήσει σε αυτήν και στα εξαρτήματά της.
As has been stated, the quality of the water in the cooling system dictates how well the system will perform. Even with good quality water, the system still needs to be treated to prevent scale and corrosion. There are many different treatments available, which are usually corrosion inhibitors and/or scale preventers. Most treatments also have some antifreeze component to give low temperature protection by lowering the freezing point of the coolant. There is also a need to protect against cavitation erosion, particularly on cylinder liners. You can click on the button to learn more about cavitation erosion when you have finished this page. The actual treatment required for a particular system is dependent to a large extent on the materials used in the system. Some treatments do not protect certain materials, and in fact can accelerate the rate of corrosion when used with them. Most treatments are therefore combinations of different chemicals which give protection to the system as a whole. You may be surprised to know that many of the treatment chemicals, nitrate and nitrite-based for example, give protection against corrosion by forming passive scale coatings on the metal surfaces, which act as a protective film against further corrosive attack. Since these protective films are very thin, there is only minor insulating effect, and heat transfer is hardly affected.
Είδαμε την καθοδική προστασία. Στο προσομοιωτή θα το δούμε και καλύτερα.
Cavitation erosion is a particular problem with wet cylinder liners. Damage caused by this mechanism can lead to corrosion problems on the water side of the liner wall. As the piston moves up and down in the cylinder liner during the cycle, the pressure in the cylinder varies. The area of the liner at which side thrust from the piston acts also varies. This variation in pressure and thrust causes the liner wall to vibrate. This vibration causes the liner wall to move in and out, affecting the volume in the water space. This leads to local pressure variations on the water side of the liner. As the liner wall moves in toward the center, the pressure on the wet side of the liner wall reduces and vapor bubbles form. As the liner wall moves back out, it creates rapid increase in local pressure, which causes the vapor bubbles to collapse. The collapsing bubbles allow the water to impact on the liner with great force. This action can break down the protective films formed by the water treatment and erode the liner metal. The damaged areas are then subject to a high risk of corrosion. Traditionally, the chemical composition of cooling water treatment was either chromate or nitrate borate based, often with the addition of silicates. The treatments commonly used today include so-called supplemental cooling additives, SCAs. These are complex compounds of soluble chemicals which provide good corrosion protection for a wide range of materials, as well as scale prevention. They often use some of the traditional treatments combined with other additives, such as molybdates and phosphates. Another traditional treatment is soluble oil. Another group of treatments are referred to as organic acid technology, but we will not consider these here as they are not common in marine use. We don't need to consider the chemistry in detail, but you should be aware of the basic way in which the treatments work. Click on the buttons for more information on the most common treatments. Chromate-based treatments work by forming a thin film on the surface of the metal components in the system. This film forms a passive barrier, which isolates the metal from any oxygen within the system, and therefore prevents oxidation and corrosion occurring. They are often combined with phosphates, which help maintain the alkalinity of the system. Chromates will not prevent scale formation. It should be noted that chromates are highly toxic and are carcinogenic, that is, they can lead to cancer. Chromate-based treatments are therefore not allowed in systems which are used to heat fresh water generators if the product is used as potable water. Nitrite-based treatments work in a similar way to chromates in that they form passive protective layers to prevent corrosion. The borate component acts to maintain alkalinity. Silicates are often included in the treatment to improve protection of aluminium components in the system. Nitrites can give rise to microbial problems, and the treatment compound often includes a biocide. Soluble oil, when used in the correct concentration, gives corrosion protection by forming a thin film over the metal surfaces. Soluble oil will not prevent scale formation. As with the other treatments considered in this module, if the protective layer formed by the treatment breaks down, then concentrated pitting corrosion will result. You should always make sure that you are familiar with the content of the materials safety data sheets for any chemicals that you have to handle on board the ship. Particular care must be taken with storage, personal protective equipment requirements, and first aid measures. The Code of Safe Working Practices also gives general guidance on handling chemicals. Many of the cooling water system chemicals are alkaline-based to ensure correct condition of the water. Acidity of the water will increase corrosion. The concentration of the treatment chemicals in cooling water systems can usually be checked by simple comparator tests. The treatments cause the water to colour, and the intensity of the colour, measured against a colour comparator, will give a direct reading of the concentration. Some treatments require the addition of an indicator solution to the sample prior to carrying out the comparator test. Other test methods include the addition of tablets until the sample colour changes. A conversion chart is then used to give the result in parts per million concentration. Any inhibitor-type treatments which use passive film formation to prevent corrosion need to be maintained at the correct concentrations. If this is not achieved, then partial breakdown of the passive film can give rise to local anodic areas, which will result in severe pitting of the metal and lead to early failure of the components. Excess concentrations of soluble oil can form insulating layers on the heat exchange surfaces, which may lead to overheating of the engine. In very high concentrations, the soluble oil may come out of solution and corrosion protection may be lost altogether. Required concentration and dosage instructions for all treatments will be given in the material safety data sheet and should be followed if adequate protection is to be achieved. The seawater side of the system may be treated to minimize or completely avoid marine growth in the pipework or on the seawater side of the heat exchangers. The treatment used may either be chemical additives or electrochlorination, which generates sodium hypochlorite from seawater. Care must be taken to use the treatment in such a way that no damage is done to the environment or marine ecology by excessive dosage or concentrations. You should always refer to the manufacturer's instructions when using any treatments. Corrosion protection can be achieved by fitting sacrificial anodes to the end covers of the individual heat exchangers. Typically, zinc is used for the anodes. As the name suggests, the anodes will corrode rather than the system metals. In this section, we have looked at the problems associated with cooling water systems and some of the treatments available to overcome these problems. We have also considered some of the basic corrosion mechanisms and seen how the various treatments act to prevent them. You should now have an understanding of the treatments and the necessity to maintain correct concentrations. Before moving on to the final assessment chapter, you should complete the end of the chapter questions to check your knowledge.
Και με αυτή την παρουσίαση ολοκληρώσαμε τον κύκλο των μαθημάτων που αφορεί την κεντρική ψήξη της κύριας μηχανής μας. Θα ακολουθήσουν και τα άλλα βασικά δίκτυα όπως είναι του αέρα, της λίπανσης, του πετρελαίου πιο εκτενέστερα, νομίζω έχω παρουσιάσει κάτι και πιστεύω ότι θα είναι κάτι χρήσιμο που θα βοηθήσει στην καλύτερη κατανόηση. Σας εύχομαι καλό απόγευμα.